Welcome to the second part of the SIListra video tutorial series. In this video, we explain how the tutorial application can be built. The general workflow demonstrated here applies for the simple tutorial as well as the full version. Only the specific files or parameters are slightly different. To start this video, we will first explain the necessary prerequisites. Then the general toolchain workflow is described. This includes the transformer usage as well as its flags, the transformation result followed by the gap left by retransformer, and as last part of the toolchain, the checker as well as its usage are described. And last but not least, we will show how to actually compile and link the application. In order to be able to build the tutorial application, we do recommend that the user has some experience with C/C++ and knows the basics of functional safety projects, has read the SIListra Safety Transformer Safety Manual before starting with the tutorial, especially the chapter Usage of the SIListra Safety Transformer. Further specific prerequisites are: you will need a working installation of the SIListra Safety Transformer accessible through the path variable which should have been set during the SIListra Safety Transformer installation. You will need a working C/C++ compiler and toolchain installed. We assume either Visual Studio Build Tools, but Clang or GCC would also work. For the simple example, we will describe the building here. However, for the other tutorials, you will need CMake. Other additional runtime dependencies will be automatically downloaded by CMake. The SIListra Safety Transformer is a command line tool. Therefore, you need to specify which and how it is supposed to transform code. This is done by passing flags to the transformer executable in the format --, flag, and then value of the flag. In order to run the transformer, we at least need to provide one source code file as input. Then it will use a default configuration. Other than that, the most important transformer flags include SIListra header, specifies the path and name of the SIListra header file, which is generated by the transformer. SIListra module, specifies the path and name of the SIListra module file, which is also generated by the transformer. fstored_inc tells the transformer to utilize the standard system include directories. I adds the given directory to the include paths. output_dir, the directory to output the generated files to. encoded file suffix, the suffix of the encoded files. In the instance of the simple example, those videos linked in the video description below, the transformer call with its flags can look something like this. As a result of the command line shown before, the transformer will generate the encoded version of the input files, the SIListra header file, named control_6 here, which contains helper functions and macros to interact with the encoded code, the SIListra module, named datasegment.c here, which contains the encoded data segment and helper variables, as well as initialization helpers. In the full application, these files are needed for the encoded channel and therefore are required in order to compile. Which brings us to the gap. At this point, after executing the transformer, the generated source code cannot yet be compiled, because of the gap intentionally left by the transformer. This gap will be filled by the checker if the generated source code from the transformer actually is correct. If you would try to compile the transformer generated source code, it would simply not compile. The gap itself are defines for specific values that are needed in order for the encoded channel to actually do any calculations. Once they are generated by the checker though, where code can be compiled normally, which brings us to the next chapter. As the name already suggests, and as has been shortly mentioned before, the checker checks and controls the code generated by the transformer on its correctness. If and only if everything is as expected, then the checker will generate the code for the gap. The generated code is a new file that, once included in the compilation, will create the full application, as it contains the missing necessary defines. In order to execute the checker, you have to use the same flags as you already used for the transformer. However, the checker has some additional flags you might find useful. The most important ones probably being report and HTML report. If they are specified, both will generate a report with additional information of the checks executed by the checker. The former as command line output, the latter as HTML. If these are not specified, the checker will simply return a short success or failed. Now for the simple example again. The call of the checker can look something like this. If errors occurred during the checking, then the gap file will not be generated and therefore the application will not be able to be compiled. If no errors occurred, then the gap file will be generated and the application can be compiled as described in the next chapter. Assuming the transformation with the transformer as well as the checking and control with the checker was successful, then we have everything we'll need to compile the application. This is done by simply providing the compiler of your choice with the files generated by the transformer, their native counterpart, and the checker generated file. The actual file names for this are already shown in the video now. Additionally, you will need to provide include directories for the compiling/linking for src encoded src/runtime. Taking these things together will result in a compiler call, as it has already been shown now in the video. For the linker, we simply refer to the build directory with a glob pattern and specify the name of the executable we want to create. The building workflow demonstrated in this video is mainly an example on how the SIListra Safety Transformer as well as the checker will interact together. It is specifically chosen to demonstrate how the simple example of your SIListra Safety Transformer installation can be transformed, checked and built. But the general workflow can be utilized to transform/build the full example or any other application. For more details on how to build, please refer to your tutorial documentation of your SIListra Safety Transformer installation or contact us directly. Visit our website on more information regarding the tutorial of the SIListra Safety Transformer 2.0 or contact us directly.